Section 1.1, Analyzing Categorical Data, Learning Targets. By the end of the section, you should be able to make and interpret bar graphs for categorical data. Identify what makes some graphs of categorical data misleading. Calculate marginal and joint relative frequencies from a two-way table. Calculate conditional relative frequencies from a two-way table. Use bar graphs to compare distributions of categorical data. Describe the nature of the association between two categorical variables. Here are the data on preferred communication method for the 10 randomly selected Canadian students from the example on page 3. In person, Facebook cell phone, in person. Text messaging, cell phone. Text messaging, text messaging, text messaging. We can summarize the distribution of this categorical variable with a frequency table or a relative frequency table. Some people use the terms frequency distribution and relative frequency distribution instead. Definition: frequency table, relative frequency table. A frequency table shows the number of individuals having each value. A relative frequency table shows the proportion or percent of individuals having each value. To make either kind of table, start by tallying the number of times that the variable takes each value. Note that the frequencies and relative frequencies listed in these tables are not data. The tables summarize the data by telling us how many or what proportion or percent of students in the sample said cell phone, Facebook, in person, and text messaging. The same process can be used to summarize the distribution of a quantitative variable. Of course, it would be hard to make a frequency table or a relative frequency table for quantitative data that take many different values, like the ages of people attending a Major League Baseball game. We'll look at a better option for quantitative variables, with many possible values in Section 1.2, Displaying Categorical Data, Bar Graphs and Pie Charts. A frequency table or relative frequency table summarizes a variable's distribution with numbers. To display the distribution more clearly, use a graph. You can make a bar graph or a pie chart for categorical data. Bar graphs are sometimes called bar charts. Pie charts are sometimes called circle graphs. Definition: bar graph, pie chart. A bar graph shows each category as a bar. The heights of the bars show the category frequencies or relative frequencies. A pie chart shows each category as a slice of the pie. The areas of the slices are proportional to the category frequencies or relative frequencies. Figure 1.2 shows a bar graph and a pie chart of the data on preferred communication method for the random sample of Canadian students. Note that the percents for each category come from the relative frequency table. It is fairly easy to make a bar graph by hand. Here's how you do it. How to make a bar graph. Draw and label the axes. Put the name of the categorical variable under the horizontal axis. To the left of the vertical axis, indicate whether the graph shows the frequency, count, or relative frequency, percent or proportion, of individuals in each category. Scale the axes. Write the names of the categories at equally spaced intervals under the horizontal axis. On the vertical axis, start at 0 and place tick marks at equal intervals until you exceed the largest frequency or relative frequency in any category. Draw bars above the category names. Make the bars equal in width and leave gaps between them. Be sure that the height of each bar corresponds to the frequency or relative frequency of individuals in that category. Making a graph is not an end in itself. The purpose of a graph is to help us understand the data. When looking at a graph, always ask, what do I see? We can see from both graphs in Figure 1.2 that the most preferred communication method for these students is text messaging. Graphs, good and bad. Bar graphs are a bit dull to look at. It is tempting to replace the bars with pictures or to use special 3D effects to make the graphs seem more interesting. Don't do it. Our eyes react to the area of the bars as well as to their height. When all bars have the same width, the area, width, x, height, varies in proportion to the height, and our eyes receive the right impression about the quantities being compared. Example: who buys IMAX? Beware the pictograph. Problem: when Apple Inc. introduced the iMac, The company wanted to know whether this new computer was expanding Apple's market share. Was the iMac mainly being bought by previous Macintosh owners, or was it being purchased by first-time computer buyers and by previous PC users who were switching over? To find out, Apple hired a firm to conduct a survey of 500 iMac customers. Each customer was categorized as a new computer purchaser, a previous PC owner, or a previous Macintosh owner. The table summarizes the survey results. A. To the right is a clever graph of the data that uses pictures instead of the more traditional bars. How is this pictograph misleading? B. Two possible bar graphs of the data are shown below. Which one could be considered deceptive? Why? Solution A. The pictograph makes it look like the percentage of iMac buyers who are former Mac owners is at least 10 times larger than either of the other two categories, which isn't true. B. The bar graph on the right is misleading. By starting the vertical scale at 10 instead of 0, it looks like the percentage of iMac buyers who previously owned a PC is less than half the percentage who are first-time computer buyers, which isn't true. There are two important lessons to be learned from this example. 1. Beware the pictograph, and 2. Watch those scales. Analyzing data on two categorical variables. You have learned some techniques for analyzing the distribution of a single categorical variable. What should you do when a dataset involves two categorical variables? For example, Yellowstone National Park staff surveyed a random sample of 1,526 winter visitors to the park. They asked each person whether he or she belonged to an environmental club, like the Sierra Club. Respondents were also asked whether they owned, rented, or had never used a snowmobile. The dataset looks something like the following. Definition. Two-way table. A two-way table is a table of counts that summarizes data on the relationship between two categorical variables for some group of individuals. It's easier to grasp the information in a two-way table if row and column totals are included, like the one shown here. Definition. Marginal relative frequency. A marginal relative frequency gives the percent or proportion of individuals that have a specific value for one categorical variable. We can compute marginal relative frequencies for the column totals to give the distribution of environmental club membership in the entire sample of 1,526 park visitors. No. 1221/1526 equals 0.800 or 80.0%. Yes. 305 divided by 1,526 equals 0.20 or 20.0%. We can compute marginal relative frequencies for the row totals to give the distribution of snowmobile use for all the individuals in the sample. Never 657 divided by 1,526 equals 0.431 or 43.1%. Rent. 574 divided by 1,526 equals 0.376 or 37.6%. Own. 295 divided by 1,526 equals 0.193 or 19.3%. Note that we could use a bar graph or a pie chart to display either of these distributions. A marginal relative frequency tells you about only one of the variables in a two-way table. It won't help you answer questions like these, which involve values of both variables. What percent of people in the sample are environmental club members and own snowmobiles? 16 divided by 1526 equals 0.01 equals 1.0%. What proportion of people in the sample are not environmental club members and never use snowmobiles? 445 divided by 1,526 equals 0.292. These percents or proportions are known as joint relative frequencies. Definition. Joint relative frequency. A joint relative frequency gives the percent or proportion of individuals that have a specific value for one categorical variable and a specific value for another categorical variable. Example, a Titanic disaster, calculating marginal and joint relative frequencies. Problem. In 1912, the luxury liner Titanic, on its first voyage across the Atlantic, struck an iceberg and sank. Some passengers got off the ship in lifeboats. but many died. The two-way table gives information about adult passengers who survived and who died by class of travel. A. What proportion of adult passengers on the Titanic survived? B. Find the distribution of class of travel for adult passengers on the Titanic using relative frequencies. C. What percent of adult Titanic passengers traveled in third class and survived? Solution. A. 442. Dividido 1207 es 0.366. B. First, 319 divided by 1,207 equals 0.264 equals 26.4%. Second, 261 divided by 1,207 equals 0.216 equals 21.6%. Third, 627 divided by 1,207 equals 0.519 equals 51.9%. C. 151 divided by 1,207 equals 0.125 equals 12.5%. Check your understanding. An article in the Journal of the American Medical Association reports the results of a study designed to see if the herb St. John's wort is effective in treating moderately severe cases of depression. The study involved 338 patients who were being treated for major depression. The subjects were randomly assigned to receive one of three treatments: St. John's wort, Zoloft, a prescription drug, or placebo, an inactive treatment, for an 8-week period. The two-way table summarizes the data from the experiment. 1. What proportion of subjects in the study were randomly assigned to take St. John's wort? Explain why this value makes sense. 2. Find the distribution of change in depression for the subjects in this study using relative frequencies. 3. What percent of subjects took Zoloft and showed a full response? Relationships between two categorical variables. Let's return to the data from the Yellowstone National Park survey of 1,526 randomly selected winter visitors. Earlier, we calculated marginal and joint relative frequencies from the two-way table. These values do not tell us much about the relationship between environmental club membership and snowmobile use for the people in the sample. Environmental club, no yes total. Snowmobile use, never used 445212657. Snowmobile renter 4977574. Snowmobile owner 2791625. Total 12213051526. We can also use the two-way table to answer questions like, what percent of environmental club members in the sample are snowmobile owners? 16 divided by 305 equals 0.052 equals 5.2%. What proportion of snowmobile renters in the sample are not environmental club members? 497를 574로 나누면 0.866입니다. These percents or proportions are known as conditional relative frequencies. Definition. Conditional relative frequency. A conditional relative frequency gives the percent or proportion of individuals that have a specific value for one categorical variable among individuals who share the same value of another categorical variable, the condition. Example, a Titanic disaster, conditional relative frequencies. Problem. In 1912, the luxury liner Titanic, on its first voyage across the Atlantic, struck an iceberg and sank. Some passengers made it off the ship in lifeboats, but many died. The two-way table gives information about adult passengers who survived and who died by class of travel. A. What proportion of survivors were third-class passengers? B. What percent of first-class passengers survived? Solution. A. 151 divided by 442 equals 0.342. B. 197 divided by 319 equals 0.618 equals 61.8%. Figure 1.3 compares the distributions of snowmobile use for Yellowstone National Park visitors who are environmental club members and those who are not environmental club members with A. A side-by-side bar graph, B. A segmented bar graph, and C. A mosaic plot. Notice that the segmented bar graph can be obtained by stacking the bars in the side-by-side bar graph for each of the two environmental club membership categories, no and yes. The bar widths in the mosaic plot are proportional to the number of survey respondents who are 305, and are not 1,221 environmental club members. Definition: side-by-side bar graph, segmented bar graph, mosaic plot. A side-by-side bar graph displays the distribution of a categorical variable for each value of another categorical variable. The bars are grouped together based on the values of one of the categorical variables and placed side by side. A segmented bar graph displays the distribution of a categorical variable as segments of a rectangle, with the area of each segment proportional to the percent of individuals in the corresponding category. A mosaic plot is a modified segmented bar graph in which the width of each rectangle is proportional to the number of individuals in the corresponding category. All three graphs in Figure 1.3 show a clear association between environmental club membership and snowmobile use in this random sample of 1,526 winter visitors to Yellowstone National Park. The environmental club members were much less likely to rent, 25.2% versus 40.7%, or own, 5.2% versus 29.0%, snowmobiles than non-club members, and more likely to never use a snowmobile, 69.5% versus 0.07%, 36.4%. Knowing whether or not a person in the sample is an environmental club member helps us predict that individual's snowmobile use. Definition: association. There is an association between two variables if knowing the value of one variable helps us predict the value of the other. If knowing the value of one variable does not help us predict the value of the other, then there is no association between the variables. Membership and snowmobile use in the sample. The blue segments would be the same height for both the yes and no groups. So would the green segments and the red segments, as shown in the graph at left. In that case, knowing whether a survey respondent is an environmental club member would not help us predict his or her snowmobile use. Which distributions should we compare? Our goal all along has been to analyze the relationship between environmental club membership and snowmobile use. For this random sample of 1,526 Yellowstone National Park visitors, we decided to calculate conditional relative frequencies of snowmobile use among environmental club members and among non-club members. Why? Because we wanted to see if environmental club membership helped us predict snowmobile use. What if we had wanted to determine whether snowmobile use helps us predict whether a person is an environmental club member? Then, we would have calculated conditional relative frequencies of environmental club membership among snowmobile owners, renters, and non-users. In general, you should calculate the distribution of the variable that you want to predict for each value of the other variable. Can we say that there is an association between environmental club membership and snowmobile use in the population of all winter visitors to Yellowstone National Park? Making this determination requires formal inference, which will have to wait until Chapter 12. Example: a Titanic disaster, conditional relative frequencies and association. Problem: in 1912, the luxury liner Titanic, on its first voyage across the Atlantic, struck an iceberg and sank. Some passengers made it off the ship in lifeboats, but many died. The two-way table gives information about adult passengers who survived and who died by class of travel. A. Find the distribution of survival status for each class of travel. Make a segmented bar graph to compare these distributions. B. Describe what the graph in Part A reveals about the association between class of travel and survival status for adult passengers on the Titanic. Solution A. First class. Survived 197 out of 319 equals 0.618 equals 61.8%. Died. 122 divided by 319 equals 0.38, 2 equals 38.2%. Second class, survived. 94 out of 261 equals 0.360 equals 36.0%. Died. 167 divided by 261 equals 0.640 equals 64.0%. Third class, survived. 151 out of 627 equals 0.241 equals 24.1%. Died. 476 divided by 627 equals 0.759 equals 75.9%. To make the segmented bar graph, draw and label the axes. Put class of travel on the horizontal axis and percent on the vertical axis. Scale the axes. Use a vertical scale from 0 to 100% with tick marks every 20%. Draw bars. Make each bar have a height of 100%. Be sure the bars are equal in width and leave spaces between them. Segment each bar based on the conditional relative frequencies you calculated. Use different colors or shading patterns to represent the two possible statuses, survived and died. Add a key to the graph that tells us which color or shading represents which status. B. Knowing a passenger's class of travel helps us predict his or her survival status. First class had the highest percentage of survivors, 61.8%, followed by second class, 36.0%, and then third class, 24.1%. Because the variable survival status has only two possible values, comparing the three distributions displayed in the segmented bar graph amounts to comparing the percent of passengers in each class of travel who survived. The bar graph in Figure 1.4 shows this comparison. Note that the bar heights do not add to 100% because each bar represents a different group of passengers on the Titanic. We offer a final caution about studying the relationship between two variables. Association does not imply causation. It may be true that being in a higher class of travel on the Titanic increased a passenger's chance of survival. However, there isn't always a cause and effect relationship between two variables, even if they are clearly associated. For example, a recent study proclaimed that people who are overweight are less likely to die within a few years than are people of normal weight. Does this mean that gaining weight will cause you to live longer? Not at all. The study included smokers, who tend to be thinner and also much more likely to die in a given period than non-smokers. Smokers increase the death rate for the normal weight category, making it appear as if being overweight is better. The moral of the story: beware other variables. Section 1.1. Summary. The distribution of a categorical variable lists the categories and gives the frequency count or relative frequency percent or proportion of individuals that fall in each category. You can use a pie chart or bar graph to display the distribution of a categorical variable. When examining any graph, ask yourself, what do I see? Beware of graphs that mislead the eye. Look at the scales to see if they have been distorted to create a particular impression. Avoid making graphs that replace the bars of a bar graph with pictures whose height and width both change. A two-way table of counts summarizes data on the relationship between two categorical variables for some group of individuals. You can use a two-way table to calculate three types of relative frequencies. A marginal relative frequency gives the percent or proportion of individuals that have a specific value for one categorical variable. Use the appropriate row, total, or column total in a two-way table when calculating a marginal relative frequency. A joint relative frequency gives the percent or proportion of individuals that have a specific value for one categorical variable and a specific value for another categorical variable. Use the value from the appropriate cell in the two-way table when calculating a joint relative frequency. A conditional relative frequency gives the percent or proportion of individuals that have a specific value for one categorical variable among individuals who share the same value of another categorical variable. The condition. Use conditional relative frequencies to compare distributions of a categorical variable for two or more groups. Use a side-by-side bar graph, a segmented bar graph, or a mosaic plot to compare the distribution of a categorical variable for two or more groups. There is an association between two variables if knowing the value of one variable helps predict the value of the other. To see whether there is an association between two categorical variables, find the distribution of one variable for each value of the other variable by calculating an appropriate set of conditional relative frequencies